Hi everyone, my name's Louisa, and in this video I'm going to use Kirchhoff's loop rule to do a quick exercise for you. So in this circuit you see that you've been given two batteries and two resistors, all in series with one another. And what we want to do is find out what is the current. And we can do that by applying Kirchhoff's loop rule as well as Ohm's law. So let's get started. The first thing we want to do is find an expression for current, which means that we want to turn this circuit into something we can analyze mathematically. That might sound a little bit complicated, but the first step is almost always going to be the same thing. We're going to walk around the circuit and find an expression that comes from that analysis. So let's start here. Our voltage is going to be 3 because we have this 3-volt battery that we're starting at the positive terminal of. We walk along, no change, and then we get here. Now this is going to drop by I times R, but we don't know what I is. So what we're just going to write is it's going to be a change of -3, which is the resistance, times I. So at this point, between the two resistors, our total voltage is 3 from the battery minus 3 times the current. So we're going to keep walking out, and we've got another resistor. So again, we're going to have to subtract I times R. In this case, the resistance is 2, so instead of subtracting 3I, we're going to subtract 2I. So our total voltage at this point is going to be 3 from the battery minus 3I from the first resistor minus 2I. Now we're going to keep walking, and now we're at the negative terminal of this 5-volt battery. So since we're looking at a 5-volt battery here and we're at the negative terminal, when we move across this gap here, the voltage is going to increase because the positive terminal of a battery is the one with higher voltage. So since it's a 5-volt battery, it's pretty easy. We're just going to add 5 to what we were looking at before. So now we're going to get to the positive side of this battery, and our new expression is the same as before, plus 5. Now, what we're going to find out is that when we walk along, we're going to hit the negative terminal of the battery that we originally started at. And that means that our voltage at this point is 0. And that means that we can take this whole equation we found and set it equal to 0. Let's take a look at another slide, and what we're going to do is we're going to stop looking at the circuit and just look at the equation. First thing we're going to do is group together the like terms, and we end up with 8 minus 5I equals 0, which you can also write as 8 equals 5I. And simply, we are just going to divide both sides by 5, and we get I equals 8 over 5, which is just 1.6 amperes. So now you can see how we used the Kirchhoff's loop rule to analyze the circuit. And then we just used our knowledge of Ohm's law and voltage equals current times resistance to find an expression that we could then analyze to identify the current in this entire circuit.